So this question is another OA, and cool. So you're given the array, integer array, and then you want to calculate the total sum of all subarray. So it comes back here. So if for one element subarray, it's going to be just by itself, right? 4, 5, and 6. And two elements going to be 4, 5, 5, 6. Three elements going to be 4, 5, 6. And if you look at the frequency for this equation, how many four occurs? 1, 2, 3. How many 5 occurs? 1, 3, 4. 6 will be the remaining, right? This will be 3. So when you're doing this, and then let's just say 4 times 3, 5 times 4, 6 times 3, and this will definitely equal to 50. So what's the algorithm behind this? The algorithm behind this is I plus 1 and then n minus I. So I plus 1 is actually represent how many ways, how many ways a subarray contains array I. So for example, I'm picking 5. So how many ways that can start with array I when I equal to 1, which is 5, right? 5, 5, 6. And how many ways that n with all contains array I and n? It's going to be 4, 5, and 4, 5, 6, right? So this is 2, this is 2. When you multiply, it's going to be 4, right? And then 5 actually occurs 4 times. So let's come back to when I equal to 0. Okay, anyway. When I equal to 0, how many 0? How many will the 4 can start? It's going to be 4 by itself, right? And how many way can 4 can end? So even though we're using this, we can reuse. This is also apply for start, apply for end, right? So 4, how many way they that is contains with n this, right? So it's 4, 5. And how about this 4, 5, 6, right? So if you multiply 1 times 3, so when you're talking about this, you're only talking about the start, like only starting position. And this one you only talk about the end of a subarray that included. So yeah, so that's it. Anyway, cool. So the solution is going to be pretty straightforward. Iteration, sum, plus the current value times the total frequency. And this should be 50. And then if you do 3, 4, 5 first, it's going to be 40. Kind of reasonable. And so on. And then just do your own things, I see you.